Hello 8th graders, your new video is for section 1.2, which is covering irrational numbers and square roots. First we need to discuss what a perfect square is, and that is just the square of a whole number. And that's the ones that you would normally think of when you hear the term square root. It is like this. So if I have square root of 64, that's going to come out nice and even, right? Remember what square root is? A number times itself that gives you that number. Okay, so -8 or -8. So in other words, 8 squared is what gave you this. So 8 squared is a perfect square. So then square root, I actually just gave you an example of a square root right here, but I'll give you another one. Square root, a number times itself, and that is equal to the inside of the radical symbol. This right here, this symbol, is the radical symbol. And so if I put a 16 inside of there, your answer could be 4, because 4 times 4 gives you that. Or it could also be -4, because -4 times -4, two negatives times each other, gives you a positive. So both of those would work. This right here, very important. The square root of a negative number is not possible. So if I try to do the square root of -4, is there anything that gives you anything times itself that would give you a -4? It's not possible, because a negative times a negative gives you a positive, and a positive times a positive also gives you a positive. So this right here is not a real number. It's not possible. So some square roots will not come out even. You have to guess and check to get the answer. And you're probably saying, what does she mean by that? I'll give you an example. Square root of 10. Does that come out evenly? Can you take a number times itself? That will give you exactly 10. You cannot. So here's what you do. Well, what's pretty close to that? Square root of 9 is pretty close to that. That comes out to 3 evenly. And the square root of 16, that comes out nice to 4. So it's got to be between there. It's got to be between 3 and 4. We know that much. Okay? And since 9 is really close to 10, you know it's got to be closer to 3 than it is to 4. So I would probably start by taking 3.1 times 3.1 and see how close that gets me. 9.61. That's pretty close, but you better check this one just to make sure it's not closer. Is 3.2 times 3.2 closer? 10.24. That is closer. So your answer is about, and you would say about 3.2. These two little wavy equal sign, that means about. It's pretty close to that. Could you get closer? Yes, you could. You could keep adding numbers out here until you get as close as you possibly can. So then irrational numbers, those cannot be written as a divided by b, a over b. They do not end and they do not repeat. They go on forever but never repeat. So an example of an irrational number, one that will never come out, is pi. The real number for pi is 3.14, It keeps going forever and it never repeats. They just cut it off right here so that we can use it in our calculations. But pi is an example of an irrational number. Real numbers are a set of both rational and irrational numbers. So both irrational and rational numbers are real numbers. Okay, so if it's rational, it's also real. If it's irrational, it is also real. Numbers that are not real, I already gave you an example of one, the square root of a negative. That is not possible. It is not real. The other most common one that would be not real would be to put a fraction with a 0 on the bottom. You can't divide something by 0. Okay, it's not possible. So that is not real. You could have 0 over 8. That would be 0. But that's different. 0 on the bottom is not real. You can't do it. Mathematically impossible to divide something by 0. So if you bring all of that knowledge with you, we'll talk about it more tomorrow. Have a good night.